If we want to solve exponential and logarithmic equations, we need to be familiar with some useful properties. And first of all is the definition of a logarithm, which says that if the log of a base b equals x, then b raised to the x power equals a. So for example, if I have the log of 2 base 3 equals x, then that means 3 to the x equals 2. You need to be able to go backwards and forwards with that definition. Okay? So if we apply that same definition to natural logs, remember the base of a natural log is e. So this says that the natural log of x is a, then e raised to the a power is x. And finally, this is a really useful little property. The natural log of e raised to the x is x. So the natural log of e to the 3x is 3x. Okay? So let's look at some examples here. When the variable is in the exponent, you're dealing with an exponential equation and you must use logarithms to solve it. So when the unknown is in the exponent, the only way we're going to figure it out is to use logarithms. So just like we can take the square root of both sides, you can also take the log of both sides. And since calculators usually work with natural logs or common logs, you're either going to take the natural log of both sides or the common log of both sides. So for this example, we'll take the common log of both sides. So I'm going to take the log of 2 to the x is equal to the log of 10. And by properties of logarithms, that x can now come around front. So I have x times the log of 2 equals the log of 10. And from that, we get that x equals the log of 10 divided by the log of 2, which is approximately, over here, log of 10, make sure you close off that with parentheses, divided by log 2. And it's about 3.322. Now let's not lose sight of what we're finding when we do this, okay? We're actually finding the power of 2 that gives us 10. So if you wanted to check your work there, you could just go 2 raised to 3.322, and we should get pretty close to 10, and we do. So let me put that here. Okay, next example. E to the 3x equals 50. Well, we definitely want to use natural logs here because we have e in there. So we're going to take the natural log of both sides. The natural log of e to the 3x is equal to the natural log of 50. And by that property that we just talked about, the natural log of e to the 3x is just 3x. So x is 1/3 the natural log of 50. And so we can go natural log 50 on our calculator, divide it by 3, and get our answer, 1.304. Next example. Okay, here we've got some algebra to do before we leap in with logarithms. So let's first of all add 3 to both sides. Divide by 2. And here we can use the one-to-one property, which says that if I have the same base over here as I do over here, I can just set the exponents equal to each other. So 2x minus 1 equals 1. 2x equals 2. So x equals 1. Keep your eye out for problems that are in the quadratic form. For example, you'll notice that e to the 2x is the square of e to the x. So we're going to use a dummy variable, a temporary variable, and let it equal e to the x. That means a squared is e to the 2x. Now let's rewrite our original problem in terms of a. So e to the 2x is a squared, and I have minus 3a plus 2 equals 0. And this is a simple factoring problem now. So I want to get a minus 3 in the middle. Factors of 2 that do that are negative 1 and negative 2. So a is 1 and 2. But we're not done because we want to know what x is. So we're done with our substitution variable, and we're now going to return to e to the x has to equal 1, and e to the x has to equal 2. So that means that x is 0 because e to the 0 is 1. And over here I'm going to take the natural log of both sides, and the natural log of e to the x is x. So those are our two answers, 0 and the natural log of 2. Alright, so those are exponential equation examples. What happens when you have logarithms? Well, you have a logarithmic equation, and you'll usually have to condense it if necessary and then convert to exponential form. So how would I solve this? The natural log of x equals 7. Well, the base of a natural log is e, so we're going to convert this to exponential form. E to the 7th is x, and on my calculator I'm going to do e to the 7th, enter, and I get 1096.6. Alright, how about this example? Let's get the log all by itself. So I have 2 natural log of x equals 5. The natural log of x equals 2.5. So e to the 2.5 equals x. And then we finish that on our calculator. E to the 2.5 is x. So 12.18 is x. Okay, this isn't a natural log, this is a log base 5, but the process is still the same. I'm going to divide both sides by 3, so I get the log of 2x base 5 is equal to 4, and then I convert to exponential form using the definition of a logarithm. So 5 to the 4th is 2x. That's 625 is 2x. So 625 divided by 2 is x. Alright, now I have more than one logarithm. So I'm going to use the properties of logarithms to condense these into one. And remember that when I add logarithms, that means I can multiply what I'm taking the log of. So I'm going to have the log of 5x times x minus 1 will equal 2. So that means I have the log of 5x squared minus 5x equals 2. And since there's no base written here, that means it's a common log, and the base is 10. So 10 to the 2nd power is equal to all of that. And we get everything over on one side. And solve it like a normal quadratic. So I'm going to divide everything by 5 and factor. I think that's going to be negative 5 there and plus 4 there. So x equals 5 and negative 4. Now it's important that you always go back to your original problem and make sure your answers will work. Remember that the domain of any logarithm is always greater than 0. So that means we cannot use negative 4, because that would make make us take the log of a negative number, which is impossible. So x equals 5 is our only answer. Okay, so once we know how to solve exponential and logarithmic equations, that means we can apply them to lots of applications. For example, if $10,000 is invested at 3.5% interest compounded continuously, how long will it take to double? So since we're using continuous compounding, we'll bring in our PERT formula. And if we want to double it, then that means if I'm starting with 10,000, I want to end up with 20,000. Our interest is 3.5 in decimal form, that's 0.035, and we want to know how long. So the thing we're looking for is in the exponent, so we're going to need to use logarithms. Let's divide everything by 10,000. And now we're ready to take the natural log of both sides. And the natural log of e to the exponent is equal to the exponent. So the natural log of 2 divided by 0.035 is t. And we work that out in our calculator. Natural log 2 parentheses divided by 0.035 is 19.8. So it's going to take approximately 20 years for it to double at 3.5% interest rate.